Hey everyone, so let us continue with the multi-threading topic. So we were looking at the lock wrappers. So we have majorly three kinds of lock wrappers. One is the lock guard, the other is the unique lock, and the third one is the scope lock. We have other one as well. We will look into them one by one. So the first one that we are going to cover today is the lock guard. So what is a lock guard? The lock guard takes a mutex. It is a simplest wrapper. It locks when you construct it and it unlocks when you destruct it. In between, you cannot unlock it. It only does this operation, locking and unlocking, during construction and destruction. And you can use it with mutex, recursive mutex, and any one of them. Let us see this with an example. We'll take a simple example. I'll create a file, lcard.cpp. Using namespace std. Now I'll also be including the mutex, hash include mutex. Now after this, we'll create a mutex first. Now I would like to create a print function which takes an ID. Let us say the ID is of the thread. So what I'll do is void print. It's a function which takes an int ID, or we can say thread ID. Right. Now inside this print function, what I would like to do is I would like to print the thread ID, whichever thread is trying to call this print function. So cout thread ID, and I'll just print the ID. Okay, we changed the name. So let us copy the same name over here. Now, if I would be having multiple threads and they are trying to call this print function, we know it is not synchronized, right? So multiple threads might be calling this print function anytime and they can like overlap. So what I'll do is I'll create a lock guard over here. So lock guard inside this mutex. Now I would be giving it a name. So let us say its name is lock or LCK. And inside this, I have to pass the mutex that we have just created. Now, when we created this, it by default took the lock. And when it will destroy or when it will unlock itself, when we are moving out of the scope, at that time, this lock will get destroyed and the lock will be unlocked. Now, this is the basic mechanism of a lock guard. Now, you cannot unlock it in between. I cannot call just lck.unlock. You do not have this functionality over here. Lock guard does not provide that functionality. Now, you might be thinking that this is inside the function call. We might have certain part of the code which is inside the function, but not inside the lock guard. Then how would we handle that? So I could have written something over here. This is not critical section. And in the same way, if I would just wrap it around a block, then you can say that this is also not a critical section after this, because the lock guard is eventually going to be destroyed once it leaves this block. So you can write your code based on certain conditions. Now this time we are just trying to make use of the lock guard with the mutex, a normal mutex. Let us also see an example with a recursive mutex. So first of all, I have to create a recursive mutex and we can name it RMTX. Now let us say we again have a print function, void print recursive, and inside the argument we are just going to pass a value n, let us say. Now a simple recursive code would have been like, if I would write some base condition which is until my n is greater than 0, it means if it is less than equals to 0, then return from here. Otherwise, just go out there and print the value. So the value of n will be printed over here. Right. Now, once we are done with this, what we can do is we can just call the print recursive with n minus 1. This is a basic function. Now, what if I have to make it synchronize or make it thread safe? How would I handle this part? So to do that, what I can do is just create a lock card, mutex, and inside this, I'll just pass the RMTX. Okay, so we have to make it recursive mutex. So this will be recursive mutex. Now, the scope of this lock card is again between the constructor and the destructor of this lock. But you can see every time we are just going inside this print recursive function, let us say my n is 2, then the first time it will go inside, it will call this lock, it will take the lock, then it will go for n minus 1, which is 1. Again, the base condition will not hit. So it will take the lock again over the same mutex. So you can see the recursive mutex can take the lock again and again over the same mutex. And once it starts going backward, after the last call, which is n equals to 0 has been made, it will start returning, and at every function end, it will just release the lock one by one over the same mutex. So this is the basic functionality of the lock card. So I hope you must have understood how we can make use of a normal mutex and a recursive mutex in the code. So in the next video, we are going to see the unique lock and how is it different from the lock guard. So let us catch up in the next video. Thank you.